There's several water quality professionals that are touting anaerobic digestion and energy capture, namely Michael Stenstrom and Diego Rosso of UCLA. And they believe that if energy recovery is fully implemented and energy conservation designs are adopted, biogas production should be sufficient to satisfy plant energy demands, making wastewater treatment completely energy sustainable. And there are a few plants around the world that are actually producing more energy from methane capture than they are using. Malmö, Sweden is one of those examples. About 200 homes are utilizing disposers to convert the food waste into fertilizer at the treatment plant and capture the methane from anaerobic digestion. Whenever I talk to folks about the use of food waste disposers, I have to address the myths and misconceptions. And they are namely that they use a lot of water, they use a lot of electricity, and they overload sewers and sewage treatment plants and cause clogging. I've listed 4 or 5 studies here. Many studies have been done around the globe, independent studies where when they look at using disposers, they don't want to rely on somebody else's study. They do their own. And all these studies come to about the same conclusion, that food waste disposer in a household application uses about 1 gallon per day per household. That's about 1% if you determine that by calculating using the fact that the American Water Works Association says we use about 65 gallons per capita per day. So that equates to about 1.5% of your daily household use of water. Not very much. Electrical usage is probably one of the more profound statements. A disposer only uses about 3 to 4 kilowatt hours a year. So you're talking that a cost of less than $1 a year to run a positive induction motor. That's the equivalent of using an incandescent bulb about 3 solid days. So it's not very much energy. And the most controversial area when I discuss food waste disposers is the effect on sewers and sewage treatment plants. And the most comprehensive study was done about 10 years ago. It was commissioned through the New York Department of Environmental Protection under the Giuliani administration. They had initial preconceptions that food waste disposers would contribute higher loadings of suspended solids and fats, oils, and grease. But subsequent videotaping of the sewers after the study yielded no additional buildup in the sewers. They did calculate increased maintenance cost, but based upon sufficient velocities in sewers, a de minimis ruling followed upon these findings that the impacts were negligible when compared to the benefits. And what about the effect on treatment plants? I said earlier a number of studies have been done around the world, and many of them come to the same conclusion, that the effect of disposers on wastewater treatment plant is limited. I think I listed the Delft study here. The Cooperative Research Center did a study as well, and they determined that about 50%, at 50% market penetration, there was an additional flow of only 0.5% greater than the mean average daily flow, and that the transport and treatment would require an additional 0.5% of energy and total cost of increasing only 0.5% as well. So it's not very significant. Certainly when you send these solids to the treatment plant, you increase the organic loading on the treatment plant. But in fact, this carbon acts as a source for biologic nutrient removal. Food waste has a higher carbon to nitrogen ratio than normal human waste, and so that extra carbon facilitates the uptake of nitrogen and phosphorus in the biologic nutrient removal schemes that are required in many states in the U.S. So, to sum things up, food waste and municipal solid waste is a major challenge for communities. Certainly climate change and greenhouse gas emissions are emerging issues for all communities. Modern wastewater treatment not only protects public health, but it provides us a tool for improving the environment through managing our food waste. So, in conclusion, diverting food waste to a treatment plant is just a practical option for diverting organics from landfills, improving soils through beneficial reuse of biosolids, lowering greenhouse gas emissions, and capturing methane for energy production.
Do you have any figures on the comparative yield of methane from a, say, entrapment in a landfill, an encapsulated landfill, per ton of organic waste versus an anaerobic digester or primary digester at a wastewater treatment plant?
Off the top of the head, the one figure that I can give you is that for every 1 ton of kitchen food waste that is diverted to a treatment plant, where you have beneficial reuse of biosolids and methane capture, you reduce carbon dioxide emissions in equivalence of a 1 ton. So it's a 1 ton per 1 ton ratio. Now, as far as efficiency, food waste typically decomposes before it reaches the landfill, or it's in the upper reaches. That's not a specific statistic that I have on an actual value that I know of. But certainly anaerobic digestion improves 20 to 40% in methane production when food waste is added to digesters.
Mentioned the effect on the sewer treatment of adding the sewer to it, the food waste to the process. Is there any numbers as to how much it increases the cost of treating the sewer versus just pure waste, or is it any significant change, or is it, you were saying it helps the digestion, does it actually help the sewer treatment process?
At 50% market penetration, your costs only increase about 0.5% with regard to energy. That's mainly because most of your energy is used in the aeration or secondary portion of the treatment. And typically blowers are on or off, and regardless of how much loading is occurring, unless they have variable frequency drives on their motors for their blowers, they either have too much oxygen or not enough. And so the energy costs are really not significant. So that's why the cost at 50% penetration from this study actually only listed an increase of about 0.5%. So not very much.